So today we're going to talk about solving linear inequalities as well as absolute value equations and inequalities. So we briefly reviewed what you should already know as far as the equations and how to use inverse operations. Today we've got three different learning goals. First, be able to solve single and compound inequalities and graph their solutions. So that's what we're going to look at in our first several examples. Then example 1D covers our second learning goal, being able to solve absolute value equations. So this is part D. Then we need to be able to rewrite and solve absolute value equations and inequalities. So inequalities are E and F and graphing their solutions. So some hints to remember, and hopefully these will come flooding back to you from your Algebra 1 knowledge. When you are dealing with inequalities, meaning that we've got these symbols instead of your equal sign, when you multiply or divide by a negative number, you have to remember to flip the symbol. So very important, if it was a greater than, you flip it to become a less than and vice versa. When you are graphing inequalities on the number line, you have to put circles on the solution numbers, and your less than and greater than symbols get open circles. The less than or equal to and the greater than or equal to get your closed circles. I remember that by the fact that a closed circle is just an open circle with something extra. You fill it in. And these symbols right here are the same as these symbols with a little something extra underneath. So if there's something extra underneath, you need the extra fill in on the circle. So one other thing that I want to talk about that I didn't type out here is that when we're solving inequalities, we want to get the variable on the left. It doesn't have to be the whole time. However, it will make your life easier if you always keep it on the left. With equations, it doesn't matter because x equals 3 is the same as 3 equals x. However, saying that 3 is less than x is not the same as saying x is less than 3. If 3 is less than x, that actually means x is greater than 3, which is obviously not the same as x is less than 3. So we want to keep the variable on the left side. If you forget and end up with a variable on the right, then I'll add another hint in here. If you end up with a variable on the right, you're going to have to flip the symbol to switch that variable. So that's what I just did on the left side there when I went from 3 is less than x to x is greater than 3. If you want to switch the variable sides, you also have to flip the symbol. So I just always try to keep mine on the left so I don't have to worry about that rule, but just in case you come across that as you're solving something different than I did, then you want to keep that in mind. So let's look at example 1A. So we want to get the variable on the left side, so that means I'm going to move this 10x to the left by subtracting. So if I want it on the left side, I move what was on the right to the left side. So that gives me negative 3x. If I moved my variables to the left, then I need to move my constants to the right. So I'm going to subtract 9 to get rid of that. So greater than or equal to negative 12 minus 9 is negative 21. So negative 3x is greater than or equal to negative 21. I need to divide by negative 3 if I want to get that x alone. So x is less than or equal to. I flipped that symbol because I divided by a negative. And again, when you multiply or divide by a negative number, you have to flip the symbol. So this is going to give me less than or equal to 7. Now, I have solved the inequality. The directions says that on inequalities, we're going to graph the solution. So that means draw yourself a lovely number line. On your number lines, you're always going to have two little marks. We've only got one number, So when you only have one number, then the other number should be 0. 0 is less than 7, so we'll put it on the left side and the 7 on the right. Open or closed circle decision. So since I've got something extra here, that means I need something extra by filling in my circle. So less than or equal to. Less than means shading to the left. So the values of x that are less than 7 are this direction on the number line. You need to shade the arrow as well because everything that is less than 7 is going to work when you plug it back into that inequality. So you're not just plugging in one answer to check. You can plug in anything that's less than 7 and it should work in that situation. All right. This next one is a compound inequality. So notice that it says we wanted to solve single and compound inequalities, and that just means here I'm going to have to subtract the 4 in multiple places. So not only do I have to do it over here, but because there's a third part, I have to do it down here as well. So that gives me 5 is less than negative 1/2 w is less than 6. To get that w alone, I need to multiply by the reciprocal. So multiply everything, all the sides, by -2. So that gives me -10. I multiplied by a negative, so I flip the symbol in both cases, and this is -12. Now, when I draw a number line, it has to be in number line order. And here, the smaller number between -10 and -12 is -12. So it needs to go on the left. -10 goes on the right. Your algebraic answer needs to match your number line order. So we need to do some switching around here to get our final answer. And whenever we switch, we flip the symbols. So our final answer is going to look like this. And one way that you can remember this, we call this, well, I call this a sandwich, because w is sandwiched between two different values. And whenever you have a sandwich, you should have your less than symbols. So these ones should get open circles because they do not have the extra equals underneath. And sandwiches, when you shade, you're shading between because w is between those two values. So that's what your graph should look like. All right, last one that goes with the first learning goal. This is an OR. We call this a disjunction if you want to know the fancy word. Sandwiches are called conjunctions. In a disjunction, make sure that in your answer you actually have the word OR, because OR is different than an AND. It's different than a sandwich. So what I want you to do is go ahead and solve both of these separately and then write your answer with an OR between them. So I want you to pause the recording, solve them real quick, then unpause, and you can watch my solution to make sure you did it correctly. But we want to make sure that you know how to do it, not just that you can watch me do it. So first I subtract the 7, so -2y is less than -4. Divide by -2. Gives me y is greater than. I had to flip the symbol because I divided by a negative. Now I'm going to solve my other one. So start it by subtracting 5. That gives me 3y is less than -3. Divide by 3 on both sides. And my other solution is y is less than -1. So I've got y is greater than 2 or y is less than -1. When I graph this, again, want them in number line order, so -1 is here, 2 is here. These are an OR. They both get open circles because they don't have the equals. Look at them each separately. Y is greater than 2. Well, here's my 2. The greater than values are above, so that would shade this part of my number line. Or y is less than -1. Well, the values less than -1 are down here. When you are graphing a disjunction, an OR, these ones should always shade the arrow ends, going opposite directions. If it doesn't, then you need to check either your algebraic solution or check your graph because something is wrong in your problem. Okay, So hopefully you feel comfortable with those. Now we're going to move on to learning goal number 2. I can solve absolute value equations. So we're going to look at part D here. So solving absolute value equations. I've got a little helper right here. We'll put a blue X by it, and we will blue X down here. I'll use blue ink too, so we can kind of color code it, what goes with what. Absolute value equations, we have to rewrite them, and we turn them into 2 separate equations. It says right here, one is going to be just like the original, except without the absolute value sign. So I'm basically just going to recopy what I had, except no absolute value symbols. So I'm going to do 2 minus 4x equals 10, no absolute value signs. My 2 separate equations on absolute values, these ones are separated by the word and. Make sure you get that word in the answer. It is part of the solution. The other equation, it says it's equal to the opposite of the original. So I keep the left side the same, 2 minus 4x, but instead of being equal to 10, I make it equal to negative 10, so just the opposite of whatever the original was. Now to solve this, I'm just going to solve it just like I would any other equation. So negative 4x equals 8, divide by negative 4, and x is negative 2. Over here, same idea, subtract 2 on both sides. Gives me negative 4x equals negative 12. Divide by negative 4. And this one, x equals positive 3. Again, the and is part of your answer. X equals negative 2 and x equals 3, meaning that both of them are going to work when you plug it back in. All right, moving on. Let's go to absolute value inequalities. With a less than or equal to symbol. So the directions up here says that less than or equal to's become ands, sandwiched between the original number and its opposite. So anytime you see an absolute value inequality that has the less than symbol, it's going to become a sandwich. And what is it sandwiched between? So we've got my 4x minus 9. It's going to be sandwiched between the original number that they gave you, so 21, and its opposite, which would be negative 21. So negative 21 is less than positive 21, so it goes on the left, and positive 21 goes here. Now, this looks exactly like what we had in example 1b. I'm going to solve it, and I'm going to graph that sandwich. So I want you to go ahead, pause the recording, solve this out real quick, and then check your solution. So hopefully you added 9 everywhere first. Gives me negative 12 is less than or equal to 4x is less than or equal to 30. Divide everything by 4. That gives me negative 3 is less than or equal to x is less than or equal to 30 divided by 4 doesn't come out evenly, but it does reduce, so it becomes 15 over 2. So that is my algebraic solution. My graph, if I can get that underneath, negative 3 is less than 15 halves, so it goes on the left side. Here's my 15 halves. These should both be closed circles because they've got the equal signs underneath. And because it's a sandwich, my shading should be in the middle. So hopefully you came up with the correct answer there. All right, last new piece of information here. Absolute value inequalities that have a greater than or equal to. These become ors. So the first inequality, just like the original, except without the absolute value sign. So negative 3x plus 10 greater than or equal to 7. They become ors. So you actually write the word or. Then it says the second, so second inequality, is going to have a flipped symbol and a switched sign. So that means we keep the left side the same, negative 3x plus 10, but we're going to flip the symbol, so we make it less than or equal to, and we change the sign of the number that we were given. So instead of 7, we're going to put negative 7. And now it looks just like example 1C. So again, I want you to do this on your own. Go ahead and solve that disjunction. Come up with your algebraic answer and then graph it and then unpause to check. So you should have subtracted 10 first. Gives me negative 3x is greater than or equal to negative 3. So divide everything by negative 3. X is less than or equal to positive 1. And I've got my or. Over here I also subtract 10, but it gives me a different result. Negative 3x is less than or equal to negative 17. So divide by negative 3. Again, when you divide by a negative, flip the symbol. Negative 17 divided by negative 3, the only thing we can do is cancel the negative. 17's prime, they're not evenly divisible, so we cannot reduce it. So there is your solution. And then when you graphed it, 1 is less than 17 thirds, so it should be in this order. They should both be closed circles. And the shading should go out to the arrows because less than 1 is this way. And greater than 17 thirds is this way. So hopefully you have that in there. One thing, I guess before I scroll, I should give you this little reminder. One thing that I think is helpful, because you have to know when you're just given the problem like E or F, you have to know whether it's a sandwich or whether it's an or. The way that I remember it, and if you already know, that's great, you may not need this, but if you don't, I actually say to myself, less than, I put a D on the end of it. So remembering that the less thans have the and, meaning it's a sandwich. And then I say greater. I know it's not spelled right, but greater sounds like great or. So those ones are the ors. So hopefully maybe if you're thinking you're going to have trouble with that, that might help you remember. All right, last problem is a word problem. Our professor announces that course grades will be computed by taking 40% of a student's project score, which is scored 0 to 100, and adding 60% of a final exam score, also 0 to 100. If a student gets an 86 on the project, what scores can she get on the final exam to get a course grade of at least 90? All right, you're going to work this on your own. The key word is at least, so you need to write an inequality and solve it. So I want you to go ahead and do that. So write something and come up with a solution and then unpause to see what you did in comparison to me. What I did is first convert my 40% to a decimal, so 0.4. Of means to multiply, so of a project score means to multiply times the project score, and it says the student got an 86 on the project, so I'm going to do that first. So course grades will be computed by taking 40% of a project score and adding, so addition, 60% of the student's exam score. Well, the exam score is what we don't know, so I'm going to make that E. We want her score to have a course grade of at least, meaning greater than or equal to, 90. So that's the inequality I'm going to solve. Here, when I multiply this out, that gives me 34.4. So then I'm going to subtract that 34.4 on both sides. So 0.6e greater than or equal to 55.6. Divide both sides by 0.6, and you probably got 92.6 repeating, hopefully, if you set that up correctly. One thing I want to point out here is I don't write 92.6% repeating on anybody's paper, and most teachers don't. So when you get a score and we're saying what scores can she get, we're saying she needs a 93. Because if she just gets a 92, it's going to be a little bit short of a 90, unless we're assuming of rounding up and all that, which we can't assume. So we're going to say that this student needs to get a 93 or better to ensure a course grade of at least a 90. You can either write it that way, or you can simply write greater than or equal to 93. All right. Do some extra practice if you think you're struggling, but that is it for this lesson.